So you're building a new PC. How do you decide what power supply to buy?
Hi, I'm Paul, this is Diane, and we are the PC Zombies, and today we're going to show you the tips and tricks we've learned over time on how to pick a power supply for a new PC build.
First, we'll show you how to use AI to determine the wattage needed.
And then we're going to show you how to pick an efficiency standard, how to pick a size of power supply, and how to make sure your graphics card cable will work with your new power supply.
Finally, we'll discuss the aesthetics, the brands, and how to buy that power supply.
So let's get to it, Di.
So the first step is to calculate how much wattage you need for your power supply.
Basically, a power supply is just giving you wattage to your components in your PC. So the first thing you want to do is make sure you know what components you're going to put in your PC. The most important ones are your CPU, and if you're using a graphics card, what graphics card are you going to use? They're going to take most of the power. And what you need to do is then add up how much power does each component you have in your PC need so that you could submit it to an AI engine. I find it easiest to use an editor like Notepad or Word. Type, I'm building a computer with the following components, and then list your components. Then add additional data. Like here I said I was using air cooling, or you may want to list the components you plan to overclock. Finally, put the question that you want it to answer. How many watts will be required for my power supply? I then copy and paste the entire question into an AI engine. Copilot's the one I like. It's a Microsoft product. It comes with Windows. It's easy to use. Put this into Copilot and then watch your answers come out. I liked how Copilot tells me what it's thinking about each component and then it adds them up for a baseline. In this case, Copilot gave a baseline of 979 watts of power. With headroom, it recommends 1300 watts, which is 30% more for safety and upgrades. Let me kind of critique this AI solution a little bit. It's going to get better over time, and it's pretty dang good right now. But there is a few things that could make it a little even better. So what I did is I looked up the real manufacturing data on each of the components to see how close it was to what it recommended. So for example, Intel has specs on their CPUs. I went in and looked up the CPU that I'm using and found those specs and put it in this list. The same is true of the graphics card. I looked up the NVIDIA 4090 chip on NVIDIA and it says exactly how much it needs, 450 watts. So I put it in the spreadsheet. In some cases, the manufacturer doesn't actually tell you the wattage, and this is usually for the low wattage things. For example, my memory, my SSDs, and in this case, I just asked Google and it told me the answer. So you could do this for any of your components, but make sure you look at the link Google gives you and make sure that it looks like it's going back to the manufacturer so you can get the real number that they recommend. And if you're overclocking, you're definitely going to have to add extra. I usually add 25% to anything I'm overclocking. If I'm overclocking my graphics card, my CPU, add 25% so you have some room to work with. It is recommended to also use 25 to 40% for headroom, so I went with my usual 30%, which was also what Copilot had used on their results. I have to admit I was surprised that we actually came up with the same baseline result, even though the actual components had different values. This was amazing. You should definitely double check Copilot's results against the big items by going to the manufacturer's data or by clicking on the link that Copilot provides to make sure that you agree with the findings. Even so, I can confirm that Copilot's recommendations for this build is great. The extra 30% headroom should cover any problems on most builds. But the quickest way to audit Copilot is to get a PSU calculator and see what it tells you. For example, Newegg has one, Corsair has one, ASUS has one. I'll put links in my description to those PSU calculators. PSU's power supply unit. But the problem with the PSU calculators is sometimes they don't include headroom, or they don't include overclocking, or they don't include other peripheral components. I actually like the Corsair one. It actually included a standard base for 4 SSDs and 2 hard drives and a few fans. So it's a good one for that.
That's pretty good.
So don't risk damaging your components in your PC because of insufficient power draw. Make sure you have enough or more than enough power if you can.
Is it possible to have too much power?
Well, actually, no. If you have a power supply that's bigger than your needs, that just means you can in future upgrade and put more powerful graphics card or something else into your computer. But having too much power doesn't mean you're going to use all the power. It just means you have more power available to you. And it also means when you're like playing a game or something and you spike on your graphics card, it's ready to give it right then and there. You don't have to worry about it ever topping out or damaging components by starving them. So now you have several ways of figuring out how much wattage you need for your new power supply. You can go from AI, which is really close, all the way down to full detail, however you want to do it. All depends on your level of OCD.
The second step is to pick an efficiency standard.
The efficiency standards for power supplies today is called 80 plus. Now 80 plus efficiency standard is telling you how much power coming out of the wall is actually converted into power going into your computer components. Originally they went for 80% efficiency, and that's where the standard comes from, and that's why it's called 80 plus. Now they have bronze, silver, gold, platinum, and titanium standards, and the highest standards are closer to about 92% efficiency.
Why is efficiency so important?
Well, efficiency is important because if you don't get an efficient power supply, what's happening is it's going to generate more heat, which means it's taking power, electricity from the outlet and generating heat instead of power to your components. That heat is wasted electricity. It also requires more cooling, which means your fans have to run more, which means they're using more electricity, and sometimes fans are noisy, especially on the low-end power supplies. They have very bad fans that can be very noisy. And the final thing is that if it's not efficient, you're going to wear out your power supply components because now they're running really hot, which is bad for a small, delicate electronic. The best way to pick it is really wait until you're shopping and then try to get the highest efficiency standard you can get for the money you're willing to pay.
The third step is to determine your graphics card cable.
The graphics card cable that goes from your power supply to your graphics card may change for different power supplies and different graphics cards. So you want to know what graphics card cable you need to make it work. Most of the NVIDIA later chips, the 40 series and the 50 series, have switched to the 12V HPWR cable. So if you want to power those, you need to make sure your power supply supports that. The best way to tell that is to see if your power supply supports the ATX 3.0 or 3.1 standard. 3.0 for 40 series, 3.1 for 50 series. If it does, then it supports that cable. And you still want to make sure that in the box when you buy it, it says that you will have that 12V HPWR cable.
So are there aesthetics you need to consider?
Yeah, so this is Diane's favorite part.
Yes.
Do I get to pick a color? Do I get to do RGB? In general, there aren't a whole lot of aesthetics issues with power supplies because for the most part, they're hidden in the back of your computer case. They're hidden in the back because they have the cables all running to all your other components, and most people want to hide those cables behind the back side of the computer. Because of that, things like the color of the power supply or RGB really isn't as important, but sometimes it does matter. I have seen that you could buy white power supplies as well as black, but I haven't seen very many high-end power supplies that are white. There is a little metal plate on the highest end Corsair power supply. It's a little magnet plate you could put on that could be white, blue, or red.
Okay.
It comes with it. And so that's about as close as you can get to the high-end power supplies. But the low-end power supplies, you might find one that's white. But look, make sure you pick out your case first. If your case isn't going to show the power supply because it's hidden in the back or in a compartment, or you got really good channeling of the cables, then really the thing that you want to worry about on aesthetics is the cables. You could pick whatever color cables, several different kinds of quality of mesh or cloth for the cables, and that's really neat. That you have to pay extra for. You buy from a company like Cable Mod, but that's worth doing. You can get like red and blue striped cables if you want, whatever you like.
Number 5, determine your form factor.
Most people building a normal size PC don't even have to worry about it. That just look for an ATX power supply. Now the form factor is important for 2 reasons. One, it needs to fit in your case, and since the case generally hides it in the back of the case, it's got a little compartment, a little bit tight oftentimes, and so you don't want a power supply that's too big to fit into your case. The other reason you care about this is you're going to screw that power supply into your case, and the case of an ATX power supply will have the screws in the right spot, so that way it will screw into your case. If you're building a really tiny computer, this is the only other forms factor that they have for power supplies, is a SFX power supply. The SFX standard is just a little smaller power supply with screw holes that are in a little bit different position so that it'll work on a small case. So if you know you're going to be trying to build a small case, who builds small case computers anyways?
Oh, I don't know. Maybe if you live in New York.
Oh yeah, you live in New York, yeah. You don't want your computer bigger than your refrigerator.
Or Japan.
Oh, there you go. All right, so there you go. That's why you would do that.
Does brand matter?
Generally speaking, no. I mean, obviously you want to get a name brand, you know, like Corsair or Asus or something like that, because you want to get a power supply you can count on. If you use an IQ to manage your other RGB components and water cooling components, then it's a really good idea to look into this because your power supply now can be read from the Corsair iLink software. You can see, diagnose what's going on with your power supply, how it's using, how much wattage is being pulled from the different components. And some, like the high-end 1600 Corsair power supply, you can actually tweak how it delivers that power.
I bet that helps when you're overclocking.
Yeah, it really helps. Being able to diagnose or even have a log of what your power supply draw was during a test that you're running while you're overclocking is really nice, because then you can tell and rule out that power is the problem.
Okay, the 7th and final step is to shop for it on Amazon.
Okay, this is the fun thing. I usually always start when I shop on Amazon. And in this case, you just want to look up the power supply and the amount of wattage that you need. That's enough to get you a list of power supplies to look at. If you know what brand you want, like Corsair, I actually recommend you go to their website and shop there, just so you have a smaller list to look at and you can see what options are available. Once you find the power supply that meets the wattage you need, just make sure the 80 plus standard is also where you want to go, and maybe there's a little price difference between one and another to determine if that's what's right for you. And that's how you buy a power supply.
Well, that's a very good, thorough explanation of power supplies.
Thanks, all right. So, hey, if you want to know how to pick other components for your PC, please subscribe.
And give us a thumbs up if you liked the video.
All right, thanks guys.
Bye, take care.